Yeah. Okay, so we've got our two rules, right? If we want to recognize a proportional relationship, the two things. Right, if we have a graph, I mean, you don't need to necessarily add this to your notes unless you haven't got it. If we would this line,
No.
no, why not?
It doesn't go through 0, 0.
Doesn't go through 0, 0. Okay. What about? Charlie, now recording you. Got from my class. About this one. Same reason, right? What about this one?
No.
Why not?
It doesn't go the same value. It doesn't go up by the same.
Brooklyn, you did put your hand up.
It doesn't. It's actually
Not very nice. So this one, not. So what we're looking for is the one that we know would show a proportional relationship is through there, yep, and it carries on. And we've got, what's this?
X called? X times Y.
Y. All right. Okay. So what we're looking for today is if we, so this shows proportional relationship. What I want to know is, can we write an equation for it? Okay. So what we're looking for today is an equation. An equation of that line. So, you got the idea of what we're looking at? I'm going to give you a table of values. Let's say this is X, this is Y. I'm going to say 0, 0. Be good. I'm going to say 1, 5. It's then going to be 2, 10, 3, 15, 4, 20, and so on. Yeah? All right. How do I know that's a proportional relationship in my own? Now, what does this one go up by every time? 5. Okay. Now, one thing to notice, look, this one goes up by 5 every time, but also importantly, is that if we go across like this, it's
2 times 5.
5. And
4 times 5.
okay, so it's always the same thing, right? So we could also see that. If I asked you, actually, can you write that down? And then so I've written another one on the right hand side. What's the difference between the left hand side one and the right hand side one? Right?
On the right hand side one, you can't. The chart's not filled in.
It's not filled out, yeah? Anything else that's different?
Also goes up by 7s.
Okay, it goes up by 7s, not 5s. So what's this one?
14. It's 21. Oh, wait,
Yeah, it's 3. So
What writes it 8? Why is it not 14? Why is it 21? No? So this would go up in 7s, but I've jumped from 1 to 3. So if I had a 2 there, it would be 14. So this one is, okay, this one would be, and how did you work that out?
by multiplying 7 by the numbers.
Okay. Understood that that was times 7, and because it's a proportional relationship, it's always going to be times 7. So if I asked you to generalize So criterion B states generalize your findings. That means put it into writing what we could do all the time. So, what do you do to the x value to find the y value? So in this case, we take the x value and we by 5. This one, we take the x value and we multiply by 7. Okay. What do you get? How do we write x times 5?
I think you could write it just x times 5. Oh, 5x. Yeah.
5x. 5 lots of whatever x is, yeah? What's this one going to be?
7x.
Alright. Now, would I be right in saying that the y number can be found by doing the x number times 5 in this case?
Yeah.
That makes sense?
Yeah.
Is the y number found by doing the x number times 7 in this case? So, how can I write that using maths rather than lots of words? So the y number can be found. What's another way of saying?
Y.
Okay, what's an easier way of saying is the answer? Y equals by the other one. Two equations. These are your equations. That's what our objective is, writing that equation. So, we want to generalize our findings, which means I can't write it like, oh, if it's 5, you do 5. If it's 7, you do. Anyone like to give it a go? How I could write it so this is a rule that I could tell someone else, and then they could apply it to their own work. Anyone want to give it a go? I'll pause the recording. So, what you basically just said is generalize your finding. To write the equation, are you writing this down? That describes the proportional relationship. Use y equals ax. I'm using a bit of generalized algebra here. Okay. I'm going to give you a bit of vocabulary now. K is called the constant of proportionality. It's called the constant of proportionality because it never changes. It's always a 5. Yeah. The constant is what the ratios go up by, or what you multiply x by to get 1. Okay. So if we were doing a criterion B assessment and you wrote that, so you've had a couple of examples, you've been told they're the equations, we've come up with this. What's the final step we need to do for a criterion B assessment? Good. Verify it by giving another example. Alright, so we'll do that in a second, once you've written it. Because I said make up your own, the process that you would have gone through, actually you probably made up the equation in your head before you wrote it down. So x and y, we start with 0, 0, and then, to be honest, I could have gone, well, 1, and then what do I need to do? I need to decide what do I multiply by, don't I? So I'm going to say 2.5. So immediately I can just go, well, y equals 2.5x. And then I can fill it out. So it's 2 and 5. It's 10 and 25. And it's 20 and 50 and so on, yeah? So I pretty much have to do the equation. All right, let me just, one thing, guys. Question for you. Does y equals 3x plus 1 give a proportional relationship? What I want you to do is create a short table with some x and y values and tell me if you think it is or not, and tell me why. So you've done one that is. I want you to now look at y equals 3x, 3 times x, but then you add 1. Does that give you a proportional relationship? Because we know that y equals 3x does, but what about 3x plus 1? Do you think it will or won't? Think it will? Do a table. So you have to do, pick a value. So let's say 4. 3 times 4 is plus 1 makes. So 13 would go there. So do a few more numbers and let's see if it shows a proportional relationship as well. Good stuff, love it. So you are quite right in what you said, in that if I do 5, I would get 16. If I got 3, I would get 10. It does go up by 3. Yes, if you then put 0, you actually get a 1 in. Alright? So this one looks by 3, but you'll notice that it doesn't, it's not times by 3, okay? Because we have the plus 1. Alright? So it's not a proportional relationship. On a graph, it would be a straight line. Exactly. It would look like this. It would go through 0, 1. Yeah, it would go through 1. Right? So, what that means is, for a proportional relationship, we can only have the multiplying bit. There's no plus 1, plus 2, or minus anything. Well done there. Okay, right. Over to you. In your books, we're going to finish this up. I believe we're on practice 4 on page 29. Yeah, that's on page 29. Practice 4, page 29. You've got some questions to do to finish this off for this unit. And that's it for the unit. And we'll have a review after the break.